I take that as a no. Go? Okay. Hello, everyone. I'm Tajik, and I'm a bad programmer. So I'm very happy to be here in Riga in this support group for bad programmers. So hopefully I can share my experiences and get some validation or some pat on the back and maybe even some help. But I've come here not just to blame myself. I want to blame my tools, right? And I know what you're thinking. I know how that sounds, right? The poor workman blames his tools. That's the old saying, and there is always truth to old sayings. But there is another one I like that I think is related, and that's the fact that when you're holding a hammer, everything starts looking like a nail, right? And the reason for that is because tools are opinionated. They are not just generic. They usually suggest some way of doing things, either by design or not, right? They make something easy and something hard, and one of the ways we could see something as a good tool or a bad tool is whether it's kind of pushing you into doing the right thing rather than the wrong thing, right? So if a tool is making the right thing easy, then it's arguably better than the one that's doing the opposite, right? But not all tools are like this. And if we're talking about specifically an object-oriented language or library or framework or however you want to call it, we could say that it's a good tool or a good language or a good library if it kind of influences your design in a good way, if it suggests the right way of doing things, of doing good object-oriented design rather than the bad one, right? Discouraging the anti-patterns, not making it easy to do things badly and wrongly, right? So what is good object-oriented programming? Now that's a controversial topic. Everybody sees it a little bit differently, but there's some things that are pretty much universally true that I will be basing this on. So object orientation in general is about putting data and operations of that data together as one single entity rather than treating those as two completely different things like we sort of traditionally used to. And two big benefits from that is that, first of all, it becomes a lot easier to just use the data directly. We don't need to know all that goes on under the hood. We don't need to know all the edge cases or the complexities of it. We are given a hopefully simple enough interface that does the right thing and that prevents us from hurting ourselves too much, right? As long as the abstraction is good, this kind of works out, right? It makes it easier to write good code, to use somebody else's code to our advantage. The other part, on the other hand, is it's easier to write the thing that we can then extend further. So as long as we hide the irrelevant details or complicated details inside the objects and we don't expose them accidentally or not to the outside, it's easier for us later to modify what those operations actually do under the hood, change the internal structure, change the underlying implementation without breaking everybody else's code, right? So for example, a hash in Perl, right? When you're using a Perl hash, you don't need to know that there is hashing involved, that there is buckets, that there is collisions, and whatever goes on in there. You just use it, right? There is simple operations assigned to a key, retrieve value from a key, and so on. And similarly, because the underlying implementation is actually mostly hidden, if tomorrow Perlcon developers decided to swap it over and use like a binary tree instead, most of the code would still work exactly the same because we don't interact with the hash algorithms, the data directly, we just use the predefined operations, right? And that's one of the good parts about object-oriented programming. And it works well if we keep those two things mostly separate when they don't influence one another, where our API, our public interface, is not defined by the underlying implementation and vice versa, right? And if we start to break that separation, it doesn't stop working, right? It doesn't completely break. It's just not as good as it could have been, right? So it's not like our code is suddenly broken because we messed those two things up. We still get some of the niceties. We still have, you know, the arrow syntax, and we don't have to pass the self around. But the actual benefits of this whole object-oriented design theory, they kind of disappear, right? We're missing out on the actually good parts. And if we look at the, for example, the Perl documentation, it actually points that out. It says in Perl 002 that it's best to consider the internal data open, that it's not something that we're supposed to be paying that much attention to from the outside perspective, right? That is just something in there, and we're supposed to just look at the operations that are provided to us, right? At the public interface, so to say. And if we look at the syntax for that in traditional Perl 5, it matches that idea pretty well, right? So we defined our objects, our classes, as packages. They have subroutines inside, and those subroutines are the methods of the objects that will be created. They are the publicly exposed operations, and the internal state is all internal, right? It's probably in there somewhere, it's probably used, but it's not something that the objects advertise very much, right? They are mostly just there because they need to be there, you know, like a plot in a porno. So, what thing that we can improve it here? This is pretty good. This is very flexible, and that's why we were able to build so much stuff on top of that and build all those wonderful tools like Moon, for example. So what can really improve? Why did we actually start working towards something different than this? Well, one thing that we could improve here is make the data structure that's kept inside somewhat specified. Because yes, it's supposed to be internal, it's supposed to be hidden, but it becomes much easier to work on the object itself, on its implementation, when we have some specification to fall back on, that we know what's supposed to be inside, what expectations do we have on it, what constraints do we put. To kind of look that over is very useful and very good. Another kind of classic problem of OOP is dependency injection. So when we have our objects, they are usually not independent. They need some other objects to work on or work with. And there is always the dilemma of should we create those ourselves as our own dependencies, or should we take them from the outside? Typically, or sometimes we want to do a little bit of both. So maybe allow injecting them from the outside, but also have some sane defaults. So that's something that we could sort of use our OO system, OO library, to help managing that. And one thing that we could also improve, which is not really related to OO, and it's more related to Perl itself, is that we could improve on the way we pass arguments to functions. Because that's, well, Perl does have subroutines signatures now, as Sawyer told us. They are there, but they're not all that great. And in object-oriented programming, we want to have a specific, clear description of what our object expects, what kind of data is supposed to go in, what do the methods actually want, how do we create the damn thing, and so on. So having a very good, very versatile scheme of describing what we actually expect to come from the outside, more than Perl does by default, would also be kind of a nice thing, right? And we could potentially put that in an OO library. So fortunately, there is a thing that does this, and it's called Moose, right? It's this wonderful tool that provides all of these three things, right? We have a description of the internal state, the data structures, the constraints on those. We have a mechanism for DI. We have much improved specification of what incoming data is supposed to come, at least for the new method, right? We can say that this is supposed to be provided in this and this and this and this, and in that form. And unfortunately, in my opinion, it has the same solution to all of these three things. So there is just one keyword that does it all, and I don't really think that it's something that should be treated as a single solution to all of these problems, because yes, that is very Perlish, to have one thing that does everything depending on how you use it. But I think that here in the object-oriented world, it's especially important to separate those things, to separate the implementation, the underlying thing, from the interface, the public thing. And if we're using the same tool to describe both, I think it kind of falls apart, and we start blurring all this difference, and it doesn't work out that well in practice. So I don't really have a problem with Moose as a whole. I have a problem with the syntax, right? I don't mind all the nice stuff going under the hood, the roles, and mostly the roles for myself personally, but I assume that there is a lot of stuff that other people like, or am I using and I don't know about it. But I don't really like the syntax. So here is an example of something that I think could have been much improved on. So if you consider a web app, right? This one will be using Moo and not Moose. So whenever I'm talking about Moose in this talk, I mean Moo, Moose, Moops, or Perl 6 for that matter, because it basically shares the same traits that are pissing me off. So in this case, it's going to be Moo, because why not? So in a web application like this, we will have some sort of roots registry, which will be a mapping between URL patterns, in this case grouped by method, for example, and the code that's supposed to handle that, right? So we have a declaration like that in Moo, which says that roots is read-write, it's a hash ref, it has some default value. So what, outside of the context and documentation and stuff like that, just looking at the code itself, what do we know about these roots? So first, is it a part of a public interface, or is it part of the internal state? Right? We could say like started with an underscore or something as a convention. Yes. Kind of, yeah. I would say it's more of a workaround, but it declares accessors, that there is a read and write accessor. So at least we know that this is something that's supposed to be changed, right? But is it really? Are you supposed to be changing those? Is a web application something that needs the routes to be created, or do you create it first and then fill it with values, right? We see that this one has a default value, so presumably you create it first and then you add stuff to it, right? But should you be creating this with the roots already or adding them later, right? Because it has a default value, but does that mean that there could be possibly a different value than the default one? I don't think it's very obvious from this. And if we look at like the broader context, it doesn't become that much better because this is a part of a real code. This is denser too, and that's where it's from. And if we now look at the documentation and the other places in the code and how the code is used, the questions become somewhat answered. So is root part of the public interface? Well, it's not documented, so we can kind of assume that it isn't, right? And again, in the answer, we don't use this object directly, usually. But if I were to subclass this and write my own thing, I would very much like to know, is that something that I can rely on? Will that be there in the future? Or am I just messing with internals that I'm not supposed to, right? Are we supposed to be changing this while the object exists, while it's running? Yes, but not through the right accessor. Right? There is a method called addRoot, which doesn't actually use the right accessor. It just kind of messes up with it in a different way. So it's described here as a read-write, but we're not supposed to be using the accessor that's generated. And in fact, it's not used in the code at all, as far as I can see. Should we be passing roots to new where we create this? Maybe. I didn't find anything that said don't do this, but if it's not part of the public interface, then probably not. But we have this fairly descriptive syntax that really doesn't answer any of these questions, right? We need to kind of reach for more information, look out to docs, to examples of use, and so on to determine what this actually is, right? Is it the specification of how the object works, or is it the internals that are there to be internal and not supposed to be accessed directly? So if this Moose syntax and this mechanics, well, you know, it's not just the syntax, there's also things happening under the hood, right? But it's not giving us these pieces of information. So what is it really good for? What is it actually doing in that piece of code? And I think the most visible thing that it's doing, it gives us an accessor, which is of course a good thing, so we can actually use the damn thing, and it handles the life cycle of it. So it creates this attribute so that we know that it's there, it's in the right format, it kind of keeps track of whether that format is preserved or not, as long as we use the accessors. So it basically just handles its lifetime, the lifecycle management, and accessing of it, right? So is this really the syntax that we want to use to say, I want this thing to be there and I want to access it internally, right? Because this tells a lot of other things that are basically unrelated to this, right? So I don't think it's a very good description, at least from that angle. And my theory, and I see this pattern, it's not an isolated example, it's an isolated example here, but I see this a lot in Moose code, both in my own and in other people's code, that it seems to be used not as much for declaring attributes and handling those attributes, but it's basically a patch to fix Perl's lackluster argument passing, and something that keeps us away from using bless, which is weird and some people don't understand it. It seems to be like the selling point, and it seems to be how people use it. A lot of the attributes you typically see declared in classes are not actual object attributes, but are just the description of what new is supposed to accept. If you think about what is required used for in Moose, or is required in Perl 6, does it mean that the attribute is required? Of course it is. You know, it's part of the object. So what does the required mean? It means that it's a required argument when you create the object, right? It doesn't describe the attribute. It's what? Sorry?
This is documented.
Yes, it is. It is. I just don't think this is the best word for it. A required attribute. Can you have a non-required attribute? So well, that's my problem with it, right? That it's Moose is all about attributes, and it is all documented in a document that says this is how you create attributes, but not all of those are attributes, right? Sometimes it's just an interface specification.
It describes an attribute.
Yes, but, well, under the hood it is an attribute, yeah.
What about the attribute you should know?
Right.
Well,
Yeah, but the thing that you should know, you shouldn't always know that it's an attribute. Okay, I'll come back to that. So this is how it seems, and that's my theory, and I started digging around, and the more I started digging around in the documentation, the more it kind of reinforced that theory. So if you look at the Perl O tutorial, which talks about Moose, it says that Moose takes care of creating new for you, and it knows about the attributes you declared, so we can set them, right? So between the lines, it reads to me a bit like new is an annoyance that you shouldn't be doing, and attributes are just settings in objects. So they are no longer internal things that we're not supposed to touch. they are the things that we're supposed to set. Right? This is the message that this piece of documentation sends. That's how I read it. If you look at Moose manual again, it's somewhat similar. It says, with Moose you concentrate on the structure of your classes, and you focus on what rather than how. Right? And how it reads to me is objects are rather than do. So it's all about the structure, and to hell with operations, they will generate themselves. It's simple enough, who cares, right? It's a little bit like, if you treat everything as a glorified struct, then it all works perfectly fine. You don't have to write new. Why wouldn't you want to? It's one of the most important operations, arguably, in the object that you create, the actual initialization. The fact that the initial state is correct. If they are supposed to be immutable, then this is going to be the final state. So you're kind of missing out on that part. But not completely, because of course you get hacks that allow you to kind of fix that problem. But I think that an issue with this is that it mostly, I don't know if it was designed for this, I suppose not, but it seems to be advertised in such a way and used in such a way that it's mostly just fixing Perl's argument handling because it wasn't good enough. And while doing that, it kind of shoves away the idea of separation of concerns in object-oriented programming. So this is another example, a piece of code that I wrote, which I'm not very proud of, but it demonstrates the issue quite well. So this is a piece of an object that was basically an adapter for this module, right? So it uses this to like create DNS records, delete them later, and so on, and it requires some credentials to be able to use it, right? And it has 3 attributes. So 2 of them are required, and 1 of them is the thing that I create later, right? So again, this require, it doesn't say what attribute is actually required for the object. It just says what it's required to create an object, which, you know, it's kind of confusing in my opinion, but it's just a matter of opinion, right? And basically, the entire dance here is creating 3 attributes instead of 1, because I want to convert incoming attributes to the ones that I actually want, right? And if you work with Moose for a while, it may seem like it's not the right way to do it, because there are other mechanisms that do exactly that in a proper way, right? I wrote it this way initially, and it passed code reviews, and everyone thought it was fine, because I forgot that build args exists. Right? And build args is arguably, or build in Perl 6, is what fits exactly this use case. It wants to convert the data that you get when creating an object into the data that the object actually needs. So converts the arguments into attributes. That's exactly what I want, right? So why don't I use it instead? Well, let's try to rewrite this thing so that it uses build args, all right? So how many of you know Moose, right? Okay, of those people, or others, who remembers how do you write build args? 4, 5? I'm not sure I remember, and I wrote these slides today. Well, no, I read them today. Of course I didn't write them today. That would be silly. So yeah, who remembers the syntax for it? Well, no problem, you can look it up. It's in the docs. Maybe it's not the easiest thing to write, but it's not that hard either. You don't write your own build args, you kind of overload the existing one, and you take an additional argument, the first one, which is the original build args, so that you later call it on the class that you're in, and there you actually initialize the attributes. And meanwhile, you can check for all the constraints that you have on the incoming data, right? So one thing that we wanted to do so far, we wanted those attributes to be required, right? So we no longer have an easy way to say required attribute, but it's not that big of a problem. We can say, oh, unless this argument contains one of these things, I want to die with some error message, right? So I can write this pretty easily, right? I don't think it was easier to write or cleaner than build, but it's more explicit. It tells the better story than the previous code. So that's nice. But there is another problem. If I want to add a type constraint now, how do I do that? There is a string type in Moose. I know how to use it with an ISA, and it's very well documented. Put it as an ISA, and there will be a type constraint, and it will be automatically checked. But if I'm not using has, how do I use it here? Do you know? I don't. I haven't looked it up, to be honest. But I don't know how to use it. I assume there is a way. Maybe there is an ISA on a string, and it's that simple. But it's much more cleaner. It's much more easy to write when it's done in the old way, right? So maybe this isn't the bad code after all, the old one, right? Is it really easier with build args than it was before? Is it more easy to extend with build args than it was before? I'm not convinced. I don't think this is the syntax that somebody kind of standing in the same position will choose over the other, right? If you don't take into account that, oh yes, those are totally 2 separate things, you know, the interface and the underlying data, I should be paying attention to this. If you're not paying attention to this explicitly, you will choose the thing that's easier to write and easier to build on, which, in my opinion, is this. And in my experience, it's this. I see much more build being used like this to kind of a fix-up of what the object got than build args, which is supposedly the right solution. So that's my problem with this. That it's making the arguably wrong thing or worse thing, yeah?
The R53B lazy thing that builds itself from the two arguments.
It could, but then it really needs to be done with the build instead of the build args, right? I think, no?
It just has a builder.
Yes. So where do you get the input data then? Right, so you need to store it as attributes, right? Exactly, okay, so that's my problem, right? Because now we're treating both those things as kind of the attributes of an object, even though the object doesn't need those as attributes. They are just incoming data.
That's true, because the attributes are basically just arguments to the constructor.
Or the actual attributes, or the object dependent. That's my problem with it, right? That I know that it's very nice to have that one keyword does it all, and it's a very Perl thing to do. And if you know what you're doing, it's a very powerful tool. But I don't think that it's a very good tool if you want to guide someone into doing the right thing. And that includes both new-coming programmers who don't maybe exactly know what they're doing, and they are just doing whatever is easier, because they assume that that's the correct thing. But it affects experienced programmers as well, who just are focused on a different thing and are just picking the easier thing to write and the easier thing to maintain. So that's my problem with it. And I think we can do a little bit better, so we can have all of those niceties without breaking that separation. But my idea for this involves just breaking has into smaller pieces. So I would maybe go for something that has a completely different syntax for incoming attributes, so the arguments to new, and then the actual attributes, right? And maybe even a separate syntax for the dependency injection related stuff, because it is kind of mixing both two concepts. And I think it would be a lot cleaner to kind of deduce things from reading the code and knowing what is what if those things actually had different names instead of some different attributes or being documented differently or being written differently in a Hungarian notation or whatever. I think those are the kind of things that deserve to be treated separately, and I would much prefer to see them that way, right? To have those arguments that we now know are exactly new arguments and nothing else. We now know that they are explicitly immutable. We're not supposed to be changing them later, which is something that Moose always wanted to go for, immutability. It says that in the documentation, but if you look at live code, most of the immutability is at the end of the file when it says package meta make immutable, and not elsewhere. So I think I would prefer to have those things split, to kind of have this explicit distinction between what's coming in, what's actually internal and you're not supposed to be touching, and what's the kind of thing that you can swap out and replace, right? And then we can keep most of the same stuff. We can keep the build as something that takes the incoming attributes, or the object arguments, we could call them, the needs, and turns them into the has's. So doing basically the job of the build args, but keeping the benefits of the declarative syntax, right? That would be nice, because we wanted this declarative syntax. That's what we're flocking towards. That's what I'm pretty sure that most of the people who use Moose, and that's my experience with Moose or Moo, don't care about the meta model, about the roles, about the mixins, about anything below this. They want the nice syntax because nobody wants to write bless. Nobody remembers the order of arguments for bless. Nobody wants to handle function arguments manually, doing type checks manually. Why would you do it if you have the nice syntax on top of it? That's, I think, what most of us actually need out of this. So I would like to put that at the forefront. So I'm not sure if this is the right solution to this, or is it even needed to fix Moose? I think there is a problem in this, because when I brought up this talk and the topic of this talk to people, and I said, I have a problem with Moose, I think the API is weird, they always said, oh, you mean this, or this, or this, or this. And I said, no, I mean this completely different thing. I say, oh yeah, that's true. So I think there is more than one problem here, and this is maybe not the perfect solution, and definitely not a solution to all of them. But I think some discussion maybe, or some debate would be beneficial. I didn't come to here for validation completely, but also to have my views questioned and the ideas criticized. So I don't think we have time for questions, to put it mildly, because there's minus 5 minutes in the talk. But if you want to talk about this further, I look like this. Meet me in the hallway track, and thank you all for coming. Have a wonderful conference. It's not there yet, but I'm escaping.
Graham. I work in Amsterdam, backend developer for Booking.com, and I'm a fanboy of Sawyer and Steven. They taught me everything I know about Perl. Husband of one, father of two. Yeah, these hairs are here for a reason. Yeah, I've lived many places, done lots of things, get off my lawn and all of that. By the way, Booking is always hiring, so if you're interested, let me know. Okay, so why? Why would you be interested in joining or making JavaScript work inside Perl? There's a technical answer, right? So why not? I mean, the thing is there, and you can do it, and you can write whatever code you need to make it run. So I'm not going to talk about that because I'm pretty sure all of us here would be interested in this kind of project. I'm going to give you a few of the reasons why we wanted to experiment along this way. And the summary is, it's having a kind of a Node.js, but in Perl. So not throwing away everything we have in the backend, which is today running on Perl, but also having a way of running JavaScript for the front end in the backend. So we do have a huge code base in production, millions of lines of code running in production. The backend is mostly Perl. We have some pieces now running also in Java, not JavaScript. The front end is Perlish. There's lots of Mason in there. Anyone here has done work with Mason before? Okay, not a lot. Anyone here likes working with Mason? You're in the correct room. Great. We have found that it's been almost impossible to modernize our front-end code, and we want to. And I'm going to go into a few of the reasons for that. So at some point, we started wondering, OK, so can we fake this? Can we not throw away the millions of lines of code in Perl and just put Node in there and migrate everything there, which is impossible? Can we fake it so that to the front end, it feels like we have something like Node, but in the back end is actually a shallow layer of JavaScript running actually on top of Perl? So can we do this, keeping all of that Perl backend pretty much untouched? So one of the reasons to do this, and I think we're not going to have a lot of time. I'm going to go over this very quickly. So there's a thing called server-side rendering, which is very important. When you move to something like Node and you go to one of these newfangled frameworks like, I don't know, Vue or React or whatever, many people fall under the temptation of doing it pure client-side. So like a single-page application where everything runs in the client. And that has a whole set of problems. And keeping the ability to run code server-side and to render the page server-side has a lot of advantages, like what I'm mentioning there, better search engine optimization and faster time to content. And of course, there's some issues with it as well. The usual thing about client-side rendering when you go to a single-page application is that you load a page, and we've all been there, and you see loading, loading, loading. Even though the page is actually doing different parts of the life cycle, you don't get the page. You're not able to see anything until everything has been loaded, because everything is actually running client-side. So the client is pulling all of the stuff, and it doesn't have anything for you ready until it has finished rendering the page. Whereas where you have server-side rendering, the first time you hit a page, you do get stuff that gets sent back to you as soon as possible. You do get to see the contents of the page before, while the client is still putting together and completing the page. But you do get a what feels like a more interactive experience. So we didn't want to lose that, because Mason gives you that. Mason does server-side rendering. Okay, another reason why to do this is front ends also deserve to be happy, right? So it's not just a world of back-end developers. They want to use modern tools and frameworks, and they actually want to use proper front-end stuff, and not something that's back-endish, that looks like front-endish, but it's actually Perl in disguise. We have found, surprise, that it's actually quite difficult to hire front-end developers when you tell them they're going to be working with Mason. And yes, it is a reality that front-end frameworks, JavaScript-based frameworks like Vue and React, and I don't know how many more, they come and go. I'm not judging about that. They want to work with them, and we found it was our place to just give them a way to do it. Okay, so what it is that we did. We started with duct tape. Duct tape is a embeddable JavaScript engine with a focus on portability and compact footprint. That's how they define themselves.
That's fine, so I'm looking for my back.
Oh, okay. Yeah, not here. So duct tape is a JavaScript engine that's written in pure C. It's very easy to work with, just basically like 2 or 3 source files that you plump into your directory and compile, and that's it. It works with pretty much any C compiler. Embedding it in XS is plain vanilla embedding. Anyone here has done XS wrappings before? Okay. Okay, I commiserate with you. There are no external dependencies for duct tape at all, so just those 3 files, and that's all you need. It's pretty fast. It's actually a compiler, so it compiles to bytecode, like Perl does. It runs on a stack machine, so this is where the speed is not that good. And we found that although it has all those advantages, it was not fast enough for what we needed to do. So then we said, okay, we embedded duct tape, works. It looks like what we want to do works. Could we embed something faster? So we went to V8. V8, according to their own page, is Google's high-performance JavaScript engine. It's written in C++, so it's harder to work with. It's more complicated. The API is much, much larger. It also requires a very modern C++ compiler, so this is where things start getting a bit complex, because if you have an already existing runtime environment, maybe you will not have the appropriate C++ compiler for that, so you need to take care of that, and so on and so forth. It's also harder to embed with XS because it's C++ and not just pure C, so XS supports that, but then, again, you're straying far from the usual XS embedding. It also has some external dependencies. One of them is ICU for all the Unicode handling. So we found that the version of ICU required by V8 clashed with a bunch of stuff that we had already in production, so it was a major pain in the ass to fix that. So this took much longer than duct tape. On the other hand, it's not very fast, and it is amazingly fast. And I'm going to show some numbers supporting that claim. It is a compiler. It's also a just-in-time compiler that actually compiles to machine code the hot paths of your code. So it does that during runtime. And it was easily fast enough for what we needed. So we said, okay, if maybe we could prototype with duct tape and then move to V8. But then we would need the wrappers that we wrote in XS to have certain characteristics. So how did we do this? At this point, we were just getting out of the prototyping step, and we were actually trying to come up with a way of putting this in production. So we realized that we needed a kind of like a universal API. So both engines running in the same way as far as a Perl developer was concerned. One thing I have to point out is that both engines had an existing Perl wrapper already, but they were different. So if you were using the existing wrapper for duct tape, or you were using the existing wrapper for V8, they had different APIs. So it was not just, you cannot just switch from one to the other easily in your Perl code. So this is one of the reasons why we came up with our own wrappers. And there are some other technical reasons that I can share with you. Just find me in the hallways and we can have a chat. So we decided that we wanted this simple universal API for both. So first, we wanted it to be object-oriented. So you can just create this virtual machine thing for both duct tape and V8. You can give it some options, but you don't need to. You can also set and get JavaScript variables from Perl. So there I'm setting foo to that array, which also means converting that array and the nested contents of the array into JavaScript values to be stored in the JavaScript engine. And of course, you can get it back. And the third large piece of the API is to evaluate a piece of JavaScript code. So you can just eval something and you get what you would expect. The universal part is there in the class. So this works exactly the same for duct tape and V8. Just changing the name of the class is all you need. So of course, there's other stuff you will want to do with your API. So you need to be able to, well, you don't need to, but this is the way we did it. You can pass a Perl sub into JavaScript So it becomes like a JavaScript function. So when you're running the JavaScript code, if there is a call to that function, it actually calls back into Perl. It passes data back into Perl. You run your Perl code, and then Perl returns something that gets converted back into JavaScript, so JavaScript can keep going. So it goes both ways. You also need a way to, when you're doing JavaScript, set timeout a function after a certain amount of time. You need a way to dispatch all of the pending timeouts. Maybe those timeouts will create more timeouts to be dispatched. So you need a way to do that, to control that. You need to support console output, some specific JavaScript stuff that's required. A way to trigger garbage collection, it's useful. And also a way to fetch all of the names of all the global objects that you have created in JavaScript. And of course, there's this is where it got interesting technically. You need to marshal data between Perl and JavaScript in a way, hopefully, that's two ways. So you need to handle the basic nested data problem. You also need to handle blessed objects in some way. So what we did is we just ignored the fact that they were blessed objects. So you convert them to JavaScript, and when you get them back, they are not blessed anymore. You need to deal with data that can almost be round-tripped, like Booleans. Perl doesn't have a concept of Booleans, so if you take a true value in JavaScript and convert it to Perl, you get something that when you want to send back to JavaScript may not be a Boolean anymore, but JavaScript does differentiate between them. So you need ways of dealing with those. Same thing with the difference between integers and floating point numbers. JavaScript doesn't have integers. Surprise, maybe. Anyone here didn't know that JavaScript didn't have integers? Okay, now you do. Yeah, only floats. Yeah, not judging. There's data that just cannot be round-tripped. So you have a JavaScript subroutine that you want to send back into Perl. That just doesn't work. V8 does support this in a very complicated way, because duct-tape doesn't support it, and we wanted to control the power that we gave our developers. We said, no, you're not going to be able to do this. You need to deal with Perl magic in some cases. So you need answers for all these questions, and we do have answers for them. Output from JavaScript, you need to know to decide what to do. You store it, and then you fetch it somewhere, or you just intersperse it with Perl output. How to handle fatal errors in JavaScript, you need to do something with them and maybe bubble them up so that they become dies in Perl or something like that. So it says examples, but I only have actually one example. I thought that was a very good question. What the hell are they celebrating Christmas? Prehistoric men? Okay, I don't see from you.
Sorry, 25 past.
Okay, so I'm gonna run over this. So this is a Fibonacci implementation in JavaScript. If you see there, that's the only difference between the two implementations, duct-tape and V8. The rest of the code is the same. So I'm not gonna show the boilerplate anymore. That's all the differentiation is by the class name that you're using. So this is an example of running that code. You see there that duct-tape and V8 on each side. The results are the same, which is awesome. And of course, the runtime is not the same. So duct-tape takes 3 minutes, 20 seconds, and V8 takes 0.2 seconds running that code. Fibonacci is an exponential algorithm, so it makes sense that you would see that kind of behavior if you put it in a log scale. And the yellow is a C implementation of the same algorithm, just as a baseline. You see how much more speed you get from V8. Okay, so what have we done with this? How are we using it so far? We examined several JavaScript frameworks and chose one of them. But I didn't do that. And we made the native Vue framework supporting server-side rendering run on our Perl Frankenstein monster. And we're currently migrating actual sets of pages from Mason. So we're moving all of the backend logic to Perl classes that are exposed as service endpoints, which can be called either locally during server-side rendering or remotely from the client. And we moved all of the front-end logic to view templates, which are universal. So the same view template can run during server-side rendering or client-side rendering, on the server or in the browser. So we're just about to serve 60% of our site's live traffic with view. So this is not an experiment anymore. It's actually running production code. It's not the Booking.com visible site. It's a site used by our partners, but it gets between 20 and 60 templates rendered per second during every day. So it's pretty high volume. What are we planning to do? We want to support better sandboxing, so limit the memory allocation and execution runtime. And this is my plea for help. There's a new engine on the block, quick JavaScript, written by this crazy French guy, Bellard, the guy who wrote the Linux emulator that runs on your browser. Yes. It's awesome code, pure C. It's much faster than duct tape. There's not a lot of documentation, so I have found it hard to get all of the information I need. So if any of you want to help, just pick me. And those are some of the things I mentioned during the talk. I don't think we have time for questions.
Oh, you've not brought a laptop? Huh? You've not brought a laptop?
Laptop.
So, we're working with HDMI. Cool.
So is there no alternative C string only vendors?
Well, it's making me really confused, and I'll take that out for now until you've unlocked the screen, because it hasn't quite, I think, understood there's a second screen yet.
on. Yeah, you can also just put it on your belt. There we go.
Hello, my name is Evgen Konkov. I am talking today about debugging with Perl. I say a few words about debug tool. Sauer says that it's not handy. We will try to debug example modulitis application. If somebody is interested in interactive debugging Apache plus mod Perl, that is possible, just drop me a message. I will say about features my debugger has. We will implement new debugger command and debugger command. Standard debugger tools are not usable, so at 2015 year I'm starting to write my own debugger. It was devel debug hooks and available for free at this address. 2 years ago I rewrite it from scratch. Now it named debug hooks because these do nothing, just emit events which we can subscribe to them. Application which we will debug today available here. It has two roads. One road which always dies and second road which dies randomly. You have two options to run this application. One from terminal, and second, you run this application on remote server. To start debugging this application, you need one thing, just set a Perl 5db environment variable and run your Perl with -d flag. You just set up this value. To make things easy, I create a small makefile where we will do this adjustment. Here's so we run our application. Here's target command. So here is controller with those two actions which dies always and randomly dies. Here I put manual breakpoint. When execution of the script reach it, we are stopped. So we can see our debugger. We can do something here. And second option, if we run this application on a remote server. We just added the parameter server and run application again. Now you connect to debugger session with native tool. You should provide AP address and port where to connect, or you can use telnet. Everything is fine. Nothing special there. We make a request. And we are at debugger. Telnet. Nothing happened. We must send command to our debugger. Here we are. Let's see next section. In our application, this action dies. How dies? We don't know, randomly. To debug this, we should do three things. First, we should dump request. I write modulitis plugin debug module, which do this. When requests arrive and after dispatch, we check if there was exceptions. Then we write to this file next information: package, file line where exception occur, and request. Its method, URL, headers, and body. Here is this file. Body, headers, line, URL. Second example. We see that application is died, and information about request and where exception occur is saved. After this, we should resend this dumped request to our applications. I will do with modulitis command reproduce. What this command does? This command opens saved request and send command to our application to set breakpoint at given package file line. Let's see what is action. This is debug plugin. Here it load class where exception occur, and then run debugger command to set breakpoint at given file and line. That's all. After we set breakpoint, this script tries to resend this request, which lead to random exceptions. So this is a request. Now we reproduce. We see this command make some requests, and last one failed. We can see we are in our debugger. When exception is reproduced, we can do many things to debug why it occurs. So which things we can do here? We can list the source code step into, step over, continue script execution, put breakpoints, return from subroutine, look our stack frames, or show look which files in our project, for example. We see how many files are loaded by this application. Here is our stack, few debugger stack frames. Advancing commands. We can list a target frame from the stack. For example, we do some steps inside die. Step 1, step 2. We do two-step and we want to list the second frame from top. L-2. So we can see we at point where we die 2 frames up. We can list code by not just list source code, we can list target subroutine. For example, we see that this modulicious exception modular and subroutine rise, and we list it. We can list not only by name. If we have subroutine and some variable, if we have code reference, we may list by code reference. So let's we take reference of our subroutine. and list. Last listing is just source code. Previous listing is compiled per code and deparsed. So this is code how Perl sees your subroutine. As I already showed, we can list code by providing file name and line, but also we can search required files in our projects. We just provide to files debugger command some regular expression, for example. Now we see a list of files which match our provided regular expression. After this, we can use file name to list source or use this number. For example, list file number 0 and line 18. Here we are. Advancing commands. As I have shown, we can list the files matched by regular expressions. We can step into step over, return to n frames up. We can set breakpoints by a file line, like this. But we can see that breakpoint is activated. It's always stopped and is how it's displayed when we're listing our code. Also, we can put breakpoints by subroutine name. We just put this subroutine name and now debugger will be stopped for every subroutine which will match this name. Actually, this is regular expression like we provide for files. So we can write something also we can put conditional breakpoints. You can see that now our breakpoint have condition. When execution reach this point, this expression will be evaluated at script context, and if it return true value, debugger is stopped and interactive shell brings up. Killer features, vars. This command will spy variable, allow to spy variables at a given stack frame, and also we can spy which value it has. At current stack frames, only one variable available, export OK. Here too, and at this stack frame, more variables available. we can spy which value they have. We can see just a reference to this subroutine, and where we see that is anonymous subroutine, but also we can look which code this subroutine has. We just assign and list. So debugging of anonymous subroutines is more handy. Next, in addition to breakpoints, we can set actions at a given point. For example, if we want to do something at this line, we can write action and when execution will reach this point, this message will appear on the screen. Also, you can provide any expression. For example, this debugger command will display content of txt variable. Very handy tool for action is that we can provide another debugger command to it. For example, we have TV debugger command which allow us to trace variable access. Access to arrays, scalars, and hashes can be traced. Now, let's see this in action. Trace variable. Often when we are at our action, we want to see what this request has and to look its contact, how we get this contact at this point. We can see full history. Action is available now, so go. We see requests are repeated. This here request is reproduced, and what here's the line where requests come. Now we can see that at our breakpoint, stash has this case: action config controller captures, and all they are created at this time. For example, module-routed was, for example, pass first artifact at this code, at this line of code. Now we can open the source of this file and make some changes. At the second line, we can see modulitis initialize module captures. This happened at line 40. Here is it. We can see its artifact module captures. Check it for definedness and then initialize it by hash. Here we can see that at line 40 it was undef, and after it it's now a hash. Even if you take reference to some value and pass to subroutine, all this history will be displayed too. Also, my debugger has kill print module, which allows us to stop debugging by writing print statements. We write print statements after debugging. We remove, then we again write. But with this module, you can stop to do this. You just put some comments and say to debugger, I want to debug this part or that, how it looks. So here's example of code. You put comment that at this point we run this debugger command or any expression you want. This command are named by iter, and there is here no name, it's just default. If you run your script with these options, both commands will be executed. If you provide some name, only this expression will be executed, or default, this one. My debugger allowed to debug everything. This is even begin, check, init, and blocks. You just adjust environment variable and run your script with debug option. You can see that we are stopped at begin. At this point, the end of script is not available yet. When we debug this block, we can continue. Check block, init block, and now we stopped it somewhere at our script. My debugger allows to debug require, do, and eval statements you just step into. You see eval expressions. Now we inside eval. Here is file and line of eval. We step each expression of eval, and now we returned back to our script and continue debugging. Here you see we are stopped at end block, and also you can notice that we come from debugger here. Stack frame is next. Main eval, main end. My debugger allows easy command implementation. What you need, you just define package name, you define subroutine which handle event message from debugger, and you subscribe your handler to debugger event. That is. To use this module, you just provide parameter at Perlcat DB. Here is our trace load command, and now we will try to use it. We adjust our environment variable with this parameter and run debugging. You can see output from our new command. Now I will show how to debug it. You know, with standard debugger that is impossible to debug debugger commands. Now we can. We just put this statement and run debugging. Now we can see after begin block when file is compiled, debugger emit load event. When event is emitted, we are stopped at our handler for this event. We display some message. We can debug, we can spy our stack and do everything. I don't know, Perl didn't show any code which is compiled at the DB package, so this is empty. We can see code at 6 frames up. It was easy to implement new commands. Yes, it was. This I will show. And main very useful feature is you can start debugging from the script. You can start another debugging session. For example, you now at T1 subroutine, we can see that we come from here, then here, and we realize that this sub should be run with different parameters. You don't require to run your application again with new parameters. You just call this subroutine with different parameters. So when it's run as encoder, it returns to or if you run with different parameters. You even start to debug this subroutine. You just put D expression and we see that debugger is started. Here's we see double D. This means we are inside another debugger session. We step into, and so we are again at this point, but at level 2. It's not limited how many debuggers you run. You can run it again with different parameters if you don't like values you get here. Again, we see third level. If we look at our stack, we see next first execution usual. We we fall into inside debugger, then we start new debugger session. This subroutine do something was T1 was called. Then we start another debugger session, and here is a frame of a current debugger. I should put a note that dbx is similar to db single one. And I want to say a few words of Modulicious Web Framework. It's very handy. Why you choose it? It's very handy. It's stable, fast, reliable. It has many features and excellent documentation. If you use it before, you must try to use it. I want to say thanks to these people: Greens, Ilmeri, Amestese, Fram, Pink Mist, Ether, Har, Leonard, and other. So, your questions? Okay, if you are interested in my debugger, you can buy it. This is price. Just drop me a message to Telegram account.
Okay, start? Okay. Thank you, folks, for coming in. I'm going to be talking about quick and dirty GUI applications and why we should make them. My name is Saif. I'm actually not a programmer. I'm a doctor. I have interests in computing, and I'm one of the executive body members of some organization called Chaos UK, which stands for Computer Assisted Orthopedic Surgeons of UK. I do some hobby 3D programming. Also, I'm interested in tissue engineering, and my talk combines programming with all of these things as well. So I'm just going to go through a few things. I'm going to talk about a bit of context, brief insight into why I'm doing what my goals are. Something about tissue engineering, which some of you may be aware of, or some of you may be a new thing. I'll be talking about something called Guide Fate, which and describing how it works. It's a little application, a little module that allows you to generate a GUI interface. I'll be giving you examples, and the examples are designed to follow through what led me to what my goals are in the tissue engineering context. Then we'll talk about reflection. We'll talk about, does it all make sense? Most programmers are working the back end. They don't work with an interface which is for general public consumption. But I work with doctors and scientists who may not all be programmers. But there is a certain, doing a GUI in Perl is difficult, at least difficult for me. And the question is whether the effort required to generate can adequately justify the rewards that I would get from it. Then I'll go on a bit of a soapbox and put the world to rights, as it were, and what I think is why it's all going horribly wrong. Then we'll have a conclusion about what it's all about. So first of all, context. So tissue engineering is a way of generating new tissue. Your body, your organs, and your tissues are made of cells which are supported by a scaffold, which is some collagen or hyaluronic acid or other some molecules. So you can take a sponge of plastic and put chondrocytes on it, which are chondrocytes are cartilage cells, and put them on the back of a nude mouse. So this nude mouse has not got an immune system, so it will not reject human cells put on it. Yeah? So you take an object the shape of a sponge, the shape of an ear, put it with human chondrocytes, put it in the mouse, and that mouse will nourish that construct until a living cartilage ear develops on its own back. Yeah? So this was an experiment done by Professor Vacanti. He used to say once he made this mouse, he could never catch him because he'd always hear him before he entered the lab. So, but things have moved on a bit. We've tried to combine it with 3D printing. We can 3D print any shape you want, and this is a modern 3D printer which is designed to print in gel and uses XY coordinates to generate a shape which you can populate with seeds and form something the shape of a heart or a kidney with cells in it. Currently, actually, we only are able to use one cell type, and most organs have multiple cells on them. Essentially, all these tissues also need a perfusion system as well, but that's a different story. So it isn't all that simple, you might think. So when you take a bit of an organ and chop it up to bits and then digest it, removing the collagen matrix, you liberate the cells, but these are a mixture of cells. I separate those cells and culture them separately, expand them, and then reconstitute them with some kind of jelly, some kind of collagen, and then reassemble them into an organ. That might work, as hasn't been done yet, but that's what our goal is. The goal is not just to create a shape of an organ, but to distribute the cells in that organ in geographically distinct areas. So the heart cells go in the heart location, the leg cells go in the leg locations, the brain cells go in the brain location. Those sort of structure, to put it simply. So these cells have to be sorted out somehow or the other. And these are multiple steps with multiple points of failure. So one thing you can do, there is a device called the fluorescence assisted cell sorter, the fax machine. And what it does is you label cells with a dye. So your dye picks up, say, chondrocytes, cartilage cells, or endothelial cells. And you can put them through an inkjet printer nozzle type thing, a piezo transducer, which propels one cell at a time past the detector. And when that detector detects a cell, that signal is amplified and passed to a little deflector plate. And that plate is charged and takes a charged particle, because the cells are pre-charged on one side with positive charge, and they will move towards the negative, the cathode, and be sorted out. So you have a way of taking a mixture of cells and sorting them out and keeping them alive still. You could do this on its side in theory, and this is what I'm trying to develop. Yeah. What I'm trying to develop is something more like a CRT, cathode ray tube. You propel the cells horizontally, and then use two plates to deflect them in 2 dimensions, and therefore ballistically launch the cells onto a surface. And therefore you have your pattern, you've created a pattern far away which represents the distribution of the cells where you want them, in the geographic location you want them to, and then create them layer by layer by layer as time goes on. And that's the goal of my project. And difficulty is that these things require a computer, program, and an interface that my colleagues will like to interact with. Not necessarily a command line tool with parameters that I pass them with various things which are not that intuitive. So we fail before we have a brilliant idea, or maybe not so brilliant, but an idea, but we can't deliver that idea because we haven't got an interface that my colleagues can use. So the first thing to do is to create an interface that non-programmers will be able to use it without having to refer to a manual, with entering all the complex parameters, and all the other things, the abstract algorithmic transformations, the motion simulation, the we can sort out later. Well, the trouble is we have sorted the rust out, we've left the most important bit to the last. And that object dies there and then. So the thing about 3D development, visualization is key. You have to be able to visualize what your target is, and you have to be able to see that you've achieved the target you want to achieve. So I need to make this fit into the paradigms that people understand. A window application or an application on a desktop that they. And it needs to be, the back end may be complicated, and that interface has to interact with a different back end. It needs to be able to do core system actions to the system, because it needs to interact with the printer through a USB interface or whatever it is. It might need to do all these things. I need to be able to script it. I need to be able to give a script to say, after this is done, you do this step, and then you do that step, and then you do that step, or maybe do something several times. And then, of course, I need to control this external device, a device which is dumb from this intelligent front end. And all this could be done, I suppose, from a web interface, and have a little web server on my little device and do it all. But to me, I'm trying to reduce the number of components and reduce lag, reduce the need for a network, in effect. The trouble is, to do all these things, you need to know a lot of things. And these are not my areas of expertise, but I shall try. So basically, in order to do this development, I tried to generate a graphical interface for my applications. This is it's interesting that the logo for Perlcon Riga is this cat. A cat that's trying to look like a camel, I think, and And it's clear that on which side of the Perl 6, Perl 5 divide that cat's after anyway. But so there are modules for GUI applications, and there are several, and they're all outdated. Not many have been developed recently, as far as I can see. WX is the way, when you look for GUI and get WX is what I come across. It's not easily installable in versions of Perl after 5.16. Qt 5 needs Perl to install it, but doesn't provide a Perl API. Yeah. Qt 4 does, and that was an old system that is the CPAN version of Qt 4 does not work. You have to get the KDE libraries from their own. TK works. It's reliable. It's long-lasting. It apparently looks ugly. It also has several primitive backend functions which make it difficult to do performance. One of the most embarrassing commentary on getting a GUI working on Perl was to use inline Python. I thought that's sort of completely. I mean, I would say that is a very regressive step from my perspective. And secondly, information on using Perl applications for GUI are getting less and less frequent these days. And there are toolkits for other things, WX, and each of them work. The difficulty I've had is that each system computer I try, whether I have a Windows machine or a Raspberry Pi or my laptop or my desktop, they all seem to have different difficulties in installing these applications. So I need to be able to have an application that runs on multiple platforms, on multiple backends. Otherwise, we are going to be using the universal backend, which is a browser window. So there are too many toolkits, too many paradigms to interact with GUI. There are too many widget types, yeah? Too many options. And I can't guarantee it'll work in all platforms, yeah? And this is a difficulty. We laud the diversity of the platforms that we have access to, but the diversity makes it sometimes just easier to avoid this desktop altogether. I don't want to try a GUI. I want to try something else, yeah? I'll go with a command line interface or something else. So back to the drawing board. Now it's easy to draw a GUI. I can take a pencil and paper and draw an interface. I could put it's got a little title bar there, it's got a menu bar, I've got labels, buttons, windows. I need to convert this into a GUI somehow or the other. And actually I can draw that on a text editor. I can take a text editor and draw that GUI. Yeah. So that GUI has is written in monospace font. It's got a little title. It's got what looks like buttons, what looks like text windows, and possibly an image box there, and some numbers that might appear. And that's easy to do in a text editor. So I can take that text, and Perl is good at parsing textual data. You can take that data and find the widgets that you've drawn through your text editor. And you should be able to generate a GUI from that. You can see from the text editor those buttons are in coordinate locations that you can actually transform into coordinates for a widget. So this is the design of the world's simplest GUI designer. Yeah. There are no tools, nothing external you have to learn. There are several toolkits it works with. It works with WX, TK, works with GTK, Qt 4. It even generates a web page, and it will even generate, if you want, a web application with the same interface from that design. So the idea is that this whole objective is to get an interface that is visual. The development is visual, and to reduce the complexity, we'll just have a handful of widgets. We don't have to have every single widget on the shelf. There's still a lot to be done, obviously, and there's plenty of bugs, and I'm not a professional, so I'm not the best for doing these things. But this is how this object works. Guide fate module links to a backend module. It takes the textual representation and extracts from it the widgets that you can find using simple regular expressions, and it extracts the widgets that it can do that. It inserts those widgets into the frame object it created, and then returns that frame object, and that's the only object you return. And that frame object gives you all the things you need to do to interact with all the widgets that you've got there. And there are only a few widgets, few interactions you can have. You can set a widget, you can get a widget's value, and you can create one. So this and it is invoked simply. Yeah, you invoke it by using guide fate, pass a textual representation, choose the backend you're going to use, and there is an assist function. It can give you some assistance on how to use that as well. And then all you do is, some of the modules return the frame, some require you to have a function that returns a frame. So you can use this kind of if the function exists, then you use that to get the frame, otherwise you use the frame object that's returned. And then all GUIs have a main loop. A main loop is a loop that you're constantly looking for the user interaction. So here's a textual representation. It's a calculator, and it looks like a calculator over there, sort of, I think. And then you can generate the same with multiple backends: TK, GTK, Qt. This one's Qt, and this one's WX. Yeah. So all these backends look roughly similar from the same backend. And all that's been changed in the code is 3 or 4 letters. It's choosing the backend of it, and to go from one to the other. So the convert function looks through all these things and says, look, I found a button with the label draw, and that when you click that button, it'll call a function button 0. If you have a button labeled logs, it'll call button 1. It sequentially identifies each widget, adds it to the frame, and allocates a callback function for that button. And you can avoid that concept. If you've done it already, you don't need to run that every time. You can have a quiet output, or you can auto-generate. You can auto-generate the script that contains all these subroutines with the labels attached to them and commentary attached to them as well, so that you can cut and paste them into your own code. So I'll give you some examples. And I just thought because the last cat was looking like a camel, I put one with a butterfly in. Sadly, my program doesn't work with Perl 6, I don't think anyway. But to go through the examples, I'm just going to get out of my browser session, and I'm going to call my launcher, which I've called an executioner, because it executes programs. So now remember what we wanted to do. We wanted to have an interactive interface with users, something that you will recognize. Yeah. So we saw the calculator earlier, and I can just put, calculate and add 68 equals, and it'll work like a calculator. If you want to see the code, I'll go through that code with you. But it is essentially very, very. It's a simple interaction with buttons and an input box. I also need some graphical input. So here's a little mini game. Rock, paper, lizard, scissors, lizard, POC. I don't know if you watch Big Bang Theory or other things, but this is an extension of the old rock, paper, scissors game, which includes Spock as well, but and lizard. So you can just choose a button that you want to say, I'm paper, and he was rock, and cover. So basically, I've been able to update that image, frame object, and update the text to say what the result would be, and I can. And the lizard's poison Spock. So all of these applications take less than a couple of 100 lines of code. They're very, very simple applications. Then we said we wanted to be able to have a complex backend, a usable interface for a complex backend. And one complex backend might be the GNU plot application. It's a complex application with lots and lots of functions. What about it's simple enough to have a text area and a drawing image. So this generates an image. This plot function generates an image, and I display that image. Very simple. So I can take a. I've got examples already coded in here. So I can take a complex torus. So this is I got it from the GNU plot website as a complex application. That code is passed onto that GNU plot backend, and the GNU plot generates the output, and I present the output to you. So the issue is this: I can make minor modifications to any of this code, and then I'll have changes in my output until I fine-tune it to what I need to do. So here's another one. Then we said we wanted to do complex back-end. We want to interact with our system, system tools. And one application that has gone or is going out of Ubuntu, which I use, is a last Perl desktop application that comes in by default in Ubuntu. There are lots of Perl back-end applications, but the last desktop application is Screenshot, or what's called Shutter. But this Perl is an easy way of using Imager. You can do a screenshot application, and you can make it supersized. You can make it more than what a screenshot application does. So this screenshot application takes every single surface it detects on that window. So I can go through all the other. It captures not just that image, but all the other surfaces that are available. I can screenshot those. I can save those screenshots. I can edit them in GIMP and call another external function. I can take multiple screenshots. So I can take a screenshot every 5 seconds. And that will allow me to make a movie of whatever I'm doing. So those things, so here you have taken a simple function and you've extended that using a few lines of code. Then another thing I wanted to do was script my application. So I made simple logo. Simple stands for Simple Integrated Modular Programming Language Experiment. I have to make some kind of acronym that goes with that. But essentially the idea is this, that I can script a language like logo, like pen up, right, forward 12, pen down. I can use random words. I can use mathematical equations in there. So, and then I can generate a logo. So I can, for instance, generate a star. It's for a simple bit of code. Yeah. So I can repeat for the number of points. I can define variables and lengths. Repeat points times 2 because every point has 2 lines going to it, and then draw a star with that. Or I can do multiple random things like generate multiple flowers of different shapes and sizes. But anyway, so here is a way of I can create a script in a language that I want of specific to my use case, and I can then display the output in the same interface. So basically, what it does do is brings to me the results of my scripting immediately. And it is more difficult to do in a command line application, and more difficult to do interactively in a command line application, or another thing. And one of the things I want to do is obviously do a robotic application. So I want to be able to control devices externally. Now I haven't connected anything over here, but I can. I don't know. What I do is it's got a picture of me now. Essentially, what the objective is that I have a method of moving my server where I want it to go, and it sends a signal to my server, which I capture with a webcam attached to that. Unfortunately, the webcam in this laptop is pointing towards me, so if I capture, it'll just capture me, I think. So it doesn't do anything very exciting. The idea is that I've created a link. I want to make sure that when I make my server go clockwise or counterclockwise, that it's actually doing the same thing. And then later on, I want to be able to send the signals to the motor, not be able to see it, but actually be able to get a visual representation of where my motors are in these directions. So these are all fairly simple to do, and I can go through any code if you want me to, but I'll do that. Leave that for, oh dear, we'll leave that for, oh, it's all going to hurt wrong. Okay, so yeah, I can go over that later. But the whole objective is that there are lots of reasons for us to make GUI applications. Lots of little things that we do, which I'm going to have to, sorry, have to go to them. Just get out of here for a minute. And sorry. Go to where I need to go. So sorry. I accidentally closed it and I'm suffering. Sorry. Okay, so here are the little examples of these things. The actual for each of those applications, and you can see hopefully that the match the image box has the name of the image that I want to you insert into that box. I can choose various images. The box I mean, obviously I've colored them in, but obviously it won't be colored in later. But you can do complex things like a new plot. Hang on, sorry. There is one for the logo so basically the menu is just defined this way. The menu there, that application has a menu to allow me to do all these things over there, which doesn't appear on file image, and that file image and example menu is there, and each of those things call a callback function when you activate them. And this is the servo motor controller textual representation. So you can see that it's quite relatively easy. Even the executioner is written in this language, and I can just, and I don't know if you remember a version of Linux called Damn Small Linux. Have you heard? Do you remember that? That was when I was little, before many of you were born. But essentially, the idea was that you'd have a little panel which have multiple buttons on it, and that was your launcher for your various applications. And you can even change a couple of lines and produce a web interface for that. So let me just see if I can do that. I'll just see if I can do that for you, give you a demo of that. So this allows me to, this execution uses that because it allows me to drop down box, and I can choose whatever interfaces are available. And I can try just try, don't know, a calculator. It's going to be an easy one, hopefully. So it opens a browser. It does two things. It starts a server, which is listen to port 8085, yeah, and it also sends a textual representation of the transformation of a browser window in HTML to the browser. So the browser interacts with that with the server, which is listening on that port, and I can put down one. There's a bit of a lag, as you can see, but and it'll hopefully work for you. Yeah. So here you've created a web application without knowing too much about modulists or anything like that at all. This uses a much more simple backend. So let's get back to the presentation. So, and you can duct tape various other things. You can duct tape, it should be duct tape, shouldn't it? It shouldn't be duct tape. Anyway, I don't know. But essentially here is an application that takes two websites, the plantslist.org. You can, plantslist.org contains a list of every plant that's been classified by scientists. And Wikipedia has got loads of pictures. So I can look for pictures for any, if I look for an asparagus, I can look up all the asparagus files. It generates the family and the genus. And the family and genus I put into Wikipedia and see if there's any images of that. So I can duct tape 2 different websites, present them on a desktop for me, and I can gradually accumulate a little local database of all these things. And it is transformative, yeah. Using a GUI makes everything different, everything better. It means that you have an instant interact. You feel you're interacting with a tool, and you can make legacy console applications interact with modern interface. And the thing about it is, the web interface is what we've all resorted to nowadays with things, and it is inappropriate for all scenarios to have a server backend to interact with always. Does seem to be a bit of overkill, and also narrows your scope. A niche that you leave behind is a niche that you lose. Yeah. So what happens is we become progressively more and more less capable. So now for my soapbox, I'll talk about, just to bore you further. Let's say a famous person says the goal of Perl is to make easy things easy and hard things possible. He also said that the power of programming language is not what it lets you do, but what it lets you do easily. So that technically hard things should be easy as well, and that's what we should. That should be what our goal is. You see. So when I started programming, long time ago, I had a ZX Spectrum. We programmed in assembly in Z8TA, or with pencil and paper. I didn't do very much more after that until I picked up a second-hand book about Perl, and I don't have the capacity to learn any other language in my brain. I don't have that. It's not possible for me to do anything else. The Spectrum program for a Spectrum is going to be a fool's errand. You know, I'm not going to be able to use any of those applications. But Perl is different. Perl is ubiquitous, but it's invisible. And why is it? I mean, you know all about this Perl superpowers, yeah? All these functions that it can do. But because Perl serves a huge number of people invisibly. It does it through the back end. It's never presented as an application in the front end. And because it's robust, because it just works in the back end, nobody sees it. And if it's invisible, it will vanish. Yeah? And no one will notice if it vanishes. And that's the whole purpose. That if you have and it's possible to make complex GUI applications in Perl. This is a slicer, which is a 3D rendering software, which is written in Perl. This was a bubble something or the other game that was written in Perl, but not many visible nowadays. As I said, ultimately what we want to do is be able to interact with the user with multiple ways, to use all our senses, our ears, your eyes, your ability to do a 3D representation. And it needs to be at the same time unconstrained by the operating system it works in, or the presence of a network. So I think it's not enough for a programming language to make hard things possible. Hard things should be easy as well. It's not enough to be usable for a program for a developer. The end user needs to be able to use that as well. So all these things that we concentrate on, having niche server-side applications, we are diverting further and further away from a very, very useful feature that I would say it shouldn't be difficult, and it isn't difficult now. Now, there is one more thing. I want to thank you guys for listening. I'm going to finish off here now. But there is a little final giveaway this time. Yeah, I'm going to give away to one of you guys randomly these things, a Raspberry Pi Zero, yeah, WA version. It's got an integrated network function. It's got partly sorted headers. It's got an SD card, which has, amongst other things, my difficult to install Guide Fate module also in there. It's got adapters for HDMI and USB for other devices that you might want to. I'll also include the 16-channel pulse width modular controller board with a DIY connector for the Raspberry Pi. I'll give you 3 servos. I'll give you a cheap webcam. And the idea is this. It is yours if you want it. Yeah? You just have to email me and let me know. And one of you will get it. The reason I'm doing this is 2 reasons. One is that I want you to invent something else. I want you to invent something, and I want you to help me because I'm not a pro at this. Yeah. So my toolkits are very flawed. They're not very good code, and it is very difficult to install the backends. It takes. The reason I put this up is because to put that Guide Fate and all the backend code in there, which is difficult to find. It's not easy to find any reliable, consistent source for any backend apart from GTK, and GTK is sadly not consistent at least in the Perl interface, not consistent. So to put that in there is difficult. It takes a good 3 or 4 hours to do that, waiting for things to download on a little Raspberry Pi, which has got a very low backend. So you're welcome to it. It's yours. Email me. I've got it in my bag now. My email address is safetynet, SAIFTYNET @gmail.com, and one of you will get it. So thank you very much. Any questions? Or is there time? There may not be time for. Oh, yes.
What did you use for drawing inside the HTML page? Using SVG or just the HTML font?
So yeah, no. I use because. Okay. So the question is, what did I use to draw in the HTML pages, the little the graphics? So to draw into HTML pages, what I did was I create an SVG file, and the SVG file is converted into JPG or bitmap depending on the backend. So GTK will happily render an SVG image presented to it, but TK will want it to be converted to some kind of binary blob, and that happens at the backend. So for those drawing applications, I used that, but there are other applications. So for my GNUplot application, GNUplot generates a PNG file. So I convert that, if necessary, to a file that is format that the backend that I'm using will react with and present it. So TK will not render SVG files or some other files very well. So it has to be converted, and which is why there is a dependency on ImageMagick for that conversion for those applications. But it's not these are not code that I invented. I just cut and paste from the internet. I look for applications. If there may be much easier ways of doing these things than I know. Well, I think I'm going to give everybody a chance. I'm going to give everybody a chance to have it. As I say, the idea is that it is difficult to put any of these toolkits. And in fact, I don't know how to. I put it on CPAN, but there's an old version on CPAN. And when you try and install it from CPAN, it tries to install all these backends. And these backends will fail in many situations because the CPAN version of these backends often don't work. They often you have to go and download them yourself. So it's sometimes easier to, and I put the instructions on GitHub. but they may be different for different systems. They certainly have been for me, for each of my computers. I've had to go through a different set of things. And it would be nice for CPAN, the modules in CPAN to be updated enough to allow this to happen more transparently, and so the best way of getting Git guide fate is actually to go to the GitHub page and download the little. I've created a little all-in-one package, a zip file which contains everything you need to do that. Hopefully, yeah. So yeah. And no other questions? Thank you very much.
Hello everyone. My name is Takayuki Kikumoto, as known as the Papix. Please call me Papi. And I'm just studying English, so I cannot use English very well. So sorry. So please forgive me if there is some rude. I use Perl in my work, and I am a board member of Japan Perl Association, which is Perl users community in Japan. By the way, I attended YAPC EU 2015 in Granada. I am very happy to attend again. In this talk, I would like to about two topics about Perl in Japan. First topic is web service development. I introduced how we use Perl on the scene of web service development. The other topic is community. I introduced status of Perl community in Japan and JPA's approach to accelerate local Perl community in Japan. My first topic is web service development using Perl in Japan. About 10 years ago, many engineers use Perl in their work in Japan. At that time, some popular SNS and portal service were using Perl, and many study sessions were held by some Perl community. So, 2028, JPA was established. But now, in 2019, Perl is not popular programming language in Japan. There are some reasons. Around 2010, some all-in-one web application framework like Ruby on Rails became popular in Japan. I think that is one of the reasons of them. Now, many Japanese engineers use Ruby on Rails, PHP, Go, Python, Scala on their work. Especially, static typing language like Go and Scala are very popular. So, many Perl codes were replaced to other languages. But we are using Perl now. JPA is still active, and they support Perl Monger and Perl community in Japan. I will talk about this in the next section. And some companies are still using Perl. My company, Hatena, is one of them. In this section, I would like to introduce a little bit of my company and talk some techniques when we use Perl. As you know, Perl is used all over the world. But I don't know much about the Perl and Perl community. I don't know much about the Perl and Perl community outside Japan. I know only Japan. So I want to discuss with you about common and difference point with us. Now, I would like to introduce our company, Showtime. Our company, Hatena, is founded in 2001. Hatena means question mark in Japanese. By the way, do you know Flipnote Hatena? That is application for Nintendo DSi. This is include our company name, Hatena, because we participate in development. Our service is, I introduced our service at first, Hatena Bookmark. This is a social bookmarking platform in Japan. This service is similar to Reddit, Hacker News, and Dacious. We developed it for about 10 years using only Perl. However, developing gradually became difficult because code is getting more and more complicated. So we replaced this service hybrid Perl to hybrid Scala and Perl. This slide, my engineer said this. Engineer explain detail in this slide. Second, I'd like to talk about Mackerel. Mackerel is server monitoring source. This service can replace of Zabbix and Nagios. All our services use Mackerel as monitoring and infrastructure management tool. This service uses Scala and Go, but some tiny script is used Perl. And Hatena Blog. I belong to Hatena Blog developer team. This service is a self-publishing blog service. WordPress, Tumblr, Medium are similar services. It was released in 2011 using Perl. I'd like to show you our technology stack. First, of course, Perl is used in this service. Hatena blog is a monolithic web application using Perl. However, nowadays, we also use Go and Scala for developing some components of our blog. And the JavaScript and TypeScript is used for front-end. We use MySQL, Redis, and Memcache as a data source, and use Nginx and Varnish. We try to use IaaS and SaaS as much as possible. So we use AWS and more services like GitHub, Slack, Mackerel, Sentry, and Jenkins. To take your product easier to image, I'll show a code size for you. Perl is written about 130,000 lines, and test code is written 20,000 lines, and JavaScript written about 43,000 lines. Next, I'd like to talk about our philosophy. We believe that minimize the code to read by developer is good for us. So we don't use existing web application framework like Modulicious and Amount2. Because when I encounter a problem with web application framework, I have to read many web application frame codes. So we build very tiny web application frame-like function using several simple C modules like plug, router simple, TextXLate, and JSONXS. In addition, we don't use convenient object relational mapping module ORM like DBIX class and class DBI. We use DBIX Sunny, that is simple DBI wrapper written by Kazebro. Our philosophy is introduced by Choyongo's talk in FC Asia. Next, I want to talk about useful tools we use in development of services. At first, Smart Args, this module written by Tokuhiro. He is very famous Perl hacker in Japan. This module provides functions argument validation. Let's see synopsis. In function func2, two variables are declared, p and q. A scalar variable p expects integer, and the scalar variable q also expects integer. But a scalar variable q is optional. This func2 can be used following code. Next, I will introduce to AWS XLay. Do you know AWS XLay? AWS XLay analyzes our production service. Analysis results are available for debugging and performance tuning. For example, AWS XLay can trace process time, externality request, and executed SQL query and fetch the logs. Awesome. But AWS XLay supported language and frameworks are C#, Go, Java, Node.js, Python, and Ruby. AWS doesn't provide XLay SDK for Perl. Don't worry. Fujiwara realized AWS XLay on Perl. He used these modules for that. At first, develop KYT prof, that is lightweight profiler for Perl. This module written by Onishi. He is, by the way, a co-founder of Hatena, and he lives in Kyoto. So I think that he named KYT means Kyoto. Usage of develop KYT prof is very simple. You just use develop KYT prof on your code. This is an example of profiling about external HTTP requests using for. We can know that URL of request is papix.net, HTTPS papix.net, and process time about 120 milliseconds. Develop KYT prof can profile these modules. Of course, you can write any profiler for develop KYT prof. Next, AWS X-Ray. This is written by Fujiwara. This is simple SDK for AWS X-Ray. And this module don't execute, this module don't execute profiling because Fujiwara planned to connect WKYT Prof and AWS X-Ray. AWS X-Ray use sampling result of WKYT Prof. So he write WKYT Prof logo X-Ray, and this module connect both. Moreover, Fujiwara writes Plug middleware X-Ray for profiling using WKYT Prof and AWS X-Ray. At last, we can use AWS X-Ray on Plug. Let's take a look at profiling results on AWS Web Console. In AWS X-Ray, one place is one HTTP request for web service. AWS X-Ray trace 10 trace per minute. In addition, some traces recorded access to data store, Redis, DBI, Memcache. This is detail of trace. DBI. So we can know this request has many data store access. In addition, we can see sanitized query and fetched rows. Cool. Next, I like to talk about app PLT. This is refactoring tool using PPI. We can replace any package, subroutine, and variable name. For example, let me see an example. Now, I want to message PM to replace sample message PM. Message PM is that, and sample PM is this. This code use module use message PM and execute message method. Let's execute PLT command and replace message PM. PLT rename underscore class message sample message. Then message PM becomes sample message. And look at code PLT command execution. After code PLT command execution, all message replace sample message. PLT command replace not only message PM file name, but also module declaration code and execution code in sample PM. Next, I talk about Shipan Nissan. This means Super Shipan Broth in Japanese. This is a simple web service that displays Shipan module needing update. One funny point, this service is written by Ruby, because this service author loves Ruby. We can know how many Shipan modules are latest, and each module's current version, current version, and the latest version, like this. At last, I'd like to introduce about AppCCU. This is experimental Shipan module written by Akiyama. AppCCU provides Shipan check updates command. If you execute it, you can see renewable Shipan modules and those changes like this. This is a HTTP exceptions change log like this. And others, we use many useful Shipan modules like this. I want to talk about them, but I don't have time to explain in detail. If you are interested, please check using MetaShipan or come to hear me. And next topic, I would like to about Perl community in Japan. As mentioned above, Perl is not popular language in Japan, but some people still use and enjoy using Perl. I introduce what are we doing for Perl monger in Japan. At first, we organized JPA, that is Perl user group in Japan. Some Perl community, some Perl companies participate in JPA and they nominate board member. Our activity costs are supported from some sponsors company. Our mission, JPA has two missions. First, we operate YAPC Japan, that is the largest Perl conference in Japan. And second, we support some local Perl some local Perl communities. Until 2015, we operated Perl conference at YAPC Asia. After that, we rebooted at YAPC Japan in 2016. YAPC Japan is operated by JPA staff and some volunteer staff. YAPC Asia was mostly held in Tokyo, but YAPC Japan was held in some cities like Hokkaido, Osaka, Fukuoka, and Okinawa. YAPC Japan is YAPC Japan is a little smaller conference than Perlcon. We held that 1 or 2 times in a year, and holding period 1.5 days, half size than Perlcon. Our conference is attended 200 people and 20 to 30 speakers. One of our efforts is support for students. When some students want to attend YAPC Japan, but they may struggle about cost of attending. So JPA invites some students and provide costs of attending because we want them to know Perl. When we request for proposal of talk, sometimes we accept proposal not related Perl because we define YAPC Japan as a conference, Perl and some topics related Perl. For example, infrastructure, team management, security, and programming education. I think this is one of the characteristic points of YAPC Japan. Of course, YAPC Japan has many advanced talks about Perl. Takahiro Shimizu's How to Build Traditional Perl Interpreters is one of them. He taught this in YAPC Tokyo, and he got a third prize in Best Talk Award in YAPC Tokyo. He speaks next day in this room. By the way, I want to tell you about schedule of next YAPC Japan. To tell the truth, schedule has not been released yet in Japan. Next, we will hold YAPC Kyoto 2020 in 27 to 28 in March. We are just preparing now. If you want to attend this, I want to support you. I'd like to introduce 2 more topics. First, a local Perl community in Japan. There are some PMs in Japan. JPA also supports these communities. For example, when they hold study session, JPA detach a famous Perl manga. In addition, JPA supports operational costs of their study session. Last topic is Perl entrance. This is introductory class of Perl. We teach Perl to inexperienced people. For detail, I spoke in YAPC EU 2015. Please take a look at this slide. Conclusion, I talk about current state of Perl in Japan. I think we have many things in common on differences. I want to interact with you about them. Thank you very much for listening. Thank you.
bit closer. That's the goal. Okay. Perl 6, great stuff like asynchronous I/O, auto-parallelization, multiple syntaxes in one program, and so on. And this is probably why we are all here. It's the name of an open-minded, strong, collaborating community. You. Hope so. It's not Perl 4. Yes, we've seen there was a Perl 4. It's not the same. It's not the same as Perl 5. And it's not to be intended to be a drop-in replacement. It's just new language. And it's no continuity of the status quo. We have in the Perl 6 ecosystem Rakudo. It's a Perl 6 compiler targeting more VM, JVM, and nowadays also JavaScript. It's Perl 6 specification conform, and it's one of many Perl 6 implementations. Even it's probably the most famous one. And Rakudo Star is a bundle of the Perl 6 compiler Rakudo and some created Perl 6 core modules. It's that what Perl 5 calls core module. In Perl 6 it's just created modules bundled with the compiler. We will see. And Rakudo Star is that what you might install as Perl. Okay. How to get them? Just go to rakudo.org, files, choose your operating system. Some people may have Windows, then choose Windows. And follow the installation instructions for your operating system or Windows. Yeah, well, this is not a joke. A lot of companies I work in have a department for operating systems and databases and Windows and Intel. That's the difference. Okay. After you have installed your compiler, you can simply run Perl 6 and your Perl 6 program. You can add a shebang line on the top of the Perl 6 program, add the executable flag, and then simply run it as usual. It's like any other language which can pass the program code on its own. You can run the Perl 6 program with parameters. You can do it the same way when you have self-contained scripts. And you can give the Perl 6 parameters either here or here. Those parameters are specified here. You have a detailed option reference later on this page, so scroll down a little bit. And that's one part where Rakudo is not that specification conform. Some of the parameters are implemented even if they are referred as won't, and some options are not implemented. So Perl 6 ---- help will give you the latest information. That's probably at the very moment important. It's also in flow. So it is to expect that some parameters are implemented in the next few months. And in difference than it's done in former Perl times, you have a Perl 6 -debug, for example, instead of Perl -d. Okay. What's most important for Perl has always been the one-liners, because there's always a Perl on your system, and you can always do one-liners because, well, it's there. So it's, well, from my perspective, the goal, what we should have Perl 6 in user bin Perl to be always there. Okay. This line looks more or less similar to the original line. But the next one, line ending tidy, which is very complicated in Perl 5, is done easily in Perl 6. Because, well, it's built in. So some one-liners are very short. Another famous is, for example, filtering. You can run Perl 6 -n for execute line by line, and then run on $_ and skip the $_ and have an easy expression. And what I'm surprised that this is important, but it was number 6 or 7 on the most used Perl one-liners. Okay, usually the line in the command line has not the same constraints like on a slide, so you can continue here, and the terminal will help you scrolling or wrapping line, whatever. And yeah, that is a one-liner adding some line numbers to an input file in Perl 6. That's a little bit longer in Perl 6 than in Perl 5. On the other way, it's much cleaner to understand. I think everyone in the room immediately understands what this code does. I don't know if it's still true. This is the same stuff, but it makes the line numbers only as wide as they need it. And that's done here. But usually you know approximately how many lines you have. Okay, that's for the examples in the day-by-day stuff. And now we are going to, let's say, understand a little bit code. And we are starting with strings because Perl is for text processing. So we have here a very simple literal string, and it's processed exactly as it's written. Here we have a string which is completely interpolated, which means we have a $pit here instead of previously famous $, because it's not supported anymore. And we get here the number of the process we are currently running in. And here we have a string containing some letters, and we increment it, and we get an incremented string. So this is what an increment postfix operator does on every string finally. And here docs are changed to, you have a q, colon, 2, and then the terminator of your here doc. You can choose, there are coming later to it, lower or an upper q, depending whether you want your HereDoc interpolated or not. But at the very moment, there's nothing in it what can or what needs to be interpolated. So I'm choosing the queue. Okay. Now we have a completely interpolated string, which has a lot of, well, more or less famous letters you might or might not know, but we are here to learn them closer. These are C special characters, and finally your C library will do special things when you print them out. So the first character, \a, bless you, is at position 0 and is one character width. And when you dump it, then \a is shown. When you print it using say or print, your terminal bells. At the very last character, that's *-1, a new line character is shown. In opposite to Perl 5, you have to add the star before the -1, because it should not happen accidentally that you have a variable containing a negative value which then takes characters from the end of the string. This is intended and not by accident. You can pass also a range to substring and then get, in this example, the tab character. And when you fetch one character, then the range ends where it starts. That's probably also important for ranges. And here is another example. You fetch from position 15 till the 12th position from the end. This is not relative, this is absolute. When you are using negative positions in substring, it's always absolute. Okay, the next one. String attributes. We have a typical Unicode character. Who didn't type it day by day? Yeah. This is how it looks like when you say it. And when you get the characters in this string, you get 1. This is one character. It has 4 codes. When you encode it, in this case, it's default to UTF-8. You get 14 bytes. And when you encode it in UTF-16, you get 12 bytes. But there is no bytes in a string. A string has characters, codes, words, whatever, but it's not a system language. You don't get memory information. Okay. But we want to do something. So, very first, we want to query some stuff from database. So, we have here a little string, capital Q, with nested delimiters, so brackets. This is nested. So you can put as much open brackets in the string as long as you close it. You have here slash delimiting the string. Q, also literal string, not interpolated, but colon X executed. Then colon VV, WW, split on words with quote protection. So if your ls returns something with shell quoting, it's respected. And then it's put in the array f. Then we have an interpolated string, or almost, but this is not nested because the open is missing. So you have to escaping misplaced delimiters or whatever, how you can see it from the parser perspective. And double Q is fully interpolated, but you can exclude stuff. For example, when you're using colon exclamation mark. In this example, we do not interpolate hashes. This is probably when you have a hash 0, then it's not interpolated. When you have a hash s, it's not interpolated. When you miss the exclamation mark h, and you have one of those, this string will not contain %s, it will contain the content of your entire hash. But our f, elements of it, and the characters in it, we want to have interpolated. So this is a %0 leaded, then length of string d and something else. So we can exactly say how wide is our integer which is printed later. We still have the character conversion and the ordinary and we get it in our example from every code point. So use it on how it's said Unicode wisely. You can concatenate strings, but in Perl 6, the string operators are using tilde instead of plain dot or whatever. And we come later to it, the number is using a plus there. And we had it in the talk of Sawyer this morning. We have an uppercase, title case, and lowercase. But unless in Perl 5, this is fully Unicode support. So if I would have Greek letters here, they would be uppercased correctly. So yeah, write down for the next example, add Greek letters. And some text processing. At first, we want to use regular expressions. Okay, it's a bad example for explaining. We have our typical hello world. then we are taking the first one from here. Then we are replacing some letters. And finally, we are replacing substring RV. This is, unlike in Perl 5, you have to use a minus RV when you have a left value which should be modifiable, and replace world by Perlcon. And then we get a very complicated greet Perlcon. But I think it should explain a lot of things you can do to text and strings. Okay, numbers. The very first, we have 4 ways to note our first million, because it's the most difficult thing to get your first, so we have more than one way. The underscores in the example doesn't carry any semantic information, it's just for readability. That's because Perl is difficult to read. The hexadecimal notation doesn't change much. It's 0x, leading, and then write your hex number. Octal is changed, has changed from leading 0 to 0, like 0x, to have a little bit more readable is not what. I mean, it's always a similar consistency. Yes, consistency was a word. So when you're choosing a different base, it's more consistent. But you can also get arbitrary bases. That's an exercise, what the number is. So, okay. And I don't know how it's in Perl 5. This is not a literal number. It's an unary operator applied to a literal number. This is important when you use arithmetics on it. We will see it here a little bit later, because Perl 6 natively supports complex little numbers. So we can simply show the square root of -1. We can have an imaginary part only. We can have generic autocolon as complex. We can have an infinite imaginary part. We can also have an infinite real part, but that's pretty common. Everyone can have it. The negative one is, like the plus here. It's an operation. You see it when you multiply it. You get here the multiplication of the real part, and the imaginary part remains 2. So use the literal notation, and then you get the correct value. And we have to change the title. Okay. One, let's say, bigger feature of Perl 6 is you can write constants by their name. So you can write a shortened constant. You can get a function returning the real value, or you can just use the built-in constant. You can use also tau to avoid multiplying p. You can use the Euler number, and you can write rational numbers as they are, but when they are printed, Perl tries when it can be printed as a decimal number, it will do. Only when it's not possible, then it will be print the rational. You can, of course, compare numbers with all the operators you might need. You can do some binary arithmetic on it. You can use prefix, postfix, and other unary operators. You can use binary operators, but unlike in Perl 5 or C or Pascal or whatever, here you have the difference. You have to put a plus in front instead of just have 2 less or 2 greater and so on. You can simply add a superscripted number for direct powering arbitrary basis. This makes it easy to write a very large prime number directly into your code for use on daily basis. Then we come to conditionals. That's pretty much the same as in most other languages. The first line, we have a very easy if-else statement. You can, of course, omit the else statement. When you have a block where something, then you can use if, else if, and else to distinguish a little bit more. You can use statement modifier. You can use unless also here, but unless does not have an else. So it's probably not that reasonable in that case. And you can also use if as a statement modifier, and then you get the correct results. You can use or upgrade some blocks using with. With is like if, but instead of proving whether the expression is true or false, it's proving whether the expression is defined or not. So, and in difference, if does not use $_. If simply evaluates the expression and lets you alone with whatever you want to do in your block or statement. With evaluates the block, whether it's defined or not, and the result is set into $_, which always can be omitted by, for example, simply add a dot. The opposite of with is without. So when you say without any or true, any is not defined, and then you get very likely a roll again. When we have a, let's say, small routine which does return an undefined value unless you have a rolled for a prime number, then you get with prime only here. You get only a defined number when you are in this return path. And when you are getting in this return path, you put with a pointy block notation the returned value instead of $_ in $n, and in the block after it you can use $n. This can be useful when you want to nest blocks or when you have more readable code, when your block is a little bit larger. You can, like with if and else if, have multiple defined proofs using with and or with. So in a case you roll from A to G and you find an A, oops, you can say after you find an A that you have to say B. You can check whether one said A before B and otherwise refuse because you have to say A or B. The next one is given. Given just takes the result and put it in $_. It doesn't prove anything at the moment. You have to prove later with whence or the else, or respectively default. And when you have such an expression, and for 2, 3, and 7, simply return the result of the polynomial, then you get the answer to the ultimate question of life, universe, and everything. You have a 20% chance to get any, and you have a 20% chance that the state machine is complaining because you didn't use with. Any when or default block immediately leaves the outer block when the inner block has been finished. So in this example, when you have a 60% chance for the numbers, int is true. It says, well, found an int computing, and then leaves the outer block. So you get nothing more than, so you wait for a computing result maybe forever. Depends. Same is for the string to check. The statement modifier, we don't have it here. Just for information, the statement modifier won't leave the outer block. Well, there is no inner block in the statement modifier. So. And to get out of this serious problem, you have a proceed or succeed. When you have a proceed, then it's like the fall through statement. Well, there is no fall through, it's mostly a comment. So you have an implicit break, as said, and proceed removes that break. So when you are coming into the int line and proceed, the next whens are proceeded. You don't know in which when you're coming. It's not a fall through. You can reach every one of that. For a string, you know in this example where you're coming into. But the succeed in our default now ensures that the state machine is no longer complaining, because the succeed at this position leaves the default block immediately and then leaves the outer block and everyone is happy. Okay, let's come to the last part, that are loops. We have the typical for stuff. So we have a small array, and for each element, just say. So we loop over the elements, call the block for each of one, executing it, and going to the next. Then we have a similar loop, but we have here a special pointy block which also writes the result back. Okay. So for each element, put the element in $n, not in $_, increments it, and write it back. This one is read-only, but it takes 2 elements in one run, and a default in case the second element is not available in a list of 3 elements. So it's a little bit cheated. So you might get something like this output in this case. When you have 4 elements and sort the list, you can also run for 2 elements by using $caret and a variable. This is a shortcut for the pointy block, and the variables, instead of here in order of appearance, are filled in alphabetically order. So it's not the first one evaluated first, it's in alphabetical order. Put it in and then passed as coming. Then, instead of using loop in different syntax notations, the well-famous C loop is using the loop statement. So we have an initializer, state an expression which is evaluated whether it's true or not, and something which is executed every round, and then executing the block. You can write infinite loops, but instead of writing bracket, semicolon, semicolon, bracket, you can just omit it and then have an infinite loop. You can get the results from the loop back. So you can run a loop, do some expressions here, and write the result back to L. And then process L. Or you put it in a list and process the list immediately. So this might be the most interesting one for the one-liners. Okay. While loops are run as long as the expression evaluates to true. The expression is evaluated before the block is executed, so the block might be entirely skipped. This is not reasonable for debug code or initializing stuff which has to be run, then while is the wrong solution. And you can use while as statement modifier too. We are a little bit short on time, otherwise I would ask you what the output is, but we don't get it. Until it's the opposite of while. it runs as long as the expression evaluates to false. So it's also evaluated before the block is executed. It can skip also the entire block, but, well, until the expression evaluates to false. And it can be used as statement modifier too. When you need a block must be run at least once, then use repeat while or repeat until. Then it's at least incremented once until it's true, or as long as it's false. So you get 10, 11, 100. Any questions in the last minute?
There is no single Perl 5 module that would be compatible with Perl 6. It's not possible to that module that would work with both.
A module that would work with both. I would say in the meaning of the question, no, it's not. And it's not sane. There are different languages, but you can write program code which can run in Perl 5 and in Perl 6. When you Google it, Elisabeth Matthijssen has wrote a lot of ecosystem stuff which allows you to have existing Perl 5 code running in Perl 6. And I would say, from what I understand from both languages, it catches 99.9%. So it's a good chance that your code will run simply out of the box with the right modules loaded.
Yeah, no, there was just something in the first slide on loops. There was maybe the one before.
That's 4.
Yeah, that's what I heard. The A and B, for example, there. The third, yeah. So they're not carried mine. Is that okay, or do they have to?
In the pointy block notation, you don't have to write my, as far as I know. Maybe JJ knows better. Do we need a my here? No. I don't think, but I'm not sure. Wouldn't. Okay.
So if you have A and B somewhere else,
It's this A and B belongs only to this block. This is the pointy block notation, and it belongs only to here. It's not defined after the statement. Yeah, I don't want to get that much into because, well, I have only 45 minutes. In fact, it evaluates to a subroutine declaration implicit with that signature and the variable names. It's the same for the string. The substring examples, the *-1 also. It evaluates to code, and giving a code parameter will cause the substring, evaluates the code, and uses the return value. It's a overloaded function and can handle multiple definitions. But I think this is maybe too far for let's just use and do the right thing. Any other questions? I know, but yeah, then?
What else is supported there? Is it open versions that all different formats like radio, etc. The box, or do they have to
I do not understand the question. Not from.
represent complex numbers in ratings and things like that that are seen as part of it.
Do you understand what he means? Okay. Maybe explain me later. I just don't understand it. So, okay. Then we are 5 minutes late. Thank you for your time.